Welcome back. We would like to continue study of homogeneous system by looking at another example. So for this example, please allow me to simply write the coefficient matrix A. Okay, so remember we are solving the system Ax equals to 0. So I would like to write the coefficient matrix A, for which we have, remember I told you no need to write this augmented system because the right hand side is 0, so it is a waste of space and time. So we shall say if this is that. Okay, so when we apply our Gaussian elimination, okay, we choose a pivot, so that row 1, nothing will do to that. We set this to 0, we set this to 0. So how do we set it to 0? What do we place in row 2? We are going to put -2 row 1 plus row 2, and then we place the result in row 2. So multiply by -2 and add, we get 0. Multiply by -2 and add 5, we get +1. Multiply by -2 and add 7, what do we get? We get +3. Okay, then in row 3 we are going to replace it with -3 row 1 plus row 3. So multiply by -3 and add 3, we get 0. Multiply by -3 and add 6, we get 0. Multiply by -3 and add 8, we get +2. So the next pivot would have been this, but below it is 0, so there's nothing for us to do. This is as far as we can go. So we have a pivot here. So this was our first pivot. Then you see the next pivot is there. There's nothing we can do. Below it is 0. Then the other pivot is there. Okay, that is our row echelon form. Remember, if we said we wanted reduced row echelon form, then we would have to set this to 0, this set to 0, and that to set to 0. But this is enough. So we can see that if you just look at the system here, how many equations do we have? We have 3 equations. Okay, yes, we have this equation here, which is depending on the coefficients, and let's assume the coefficient were that. So we have that 2x2 plus 2x3 equals to 0, and then the second equation here will be x2 plus 3x3 equals to 0, and then the last equation here will be that 2x3 equals to 0. So we have 3 equations. And how many unknowns do we have? The unknowns are x1, x2, and x3 are 3. So 3 equations, 3 unknowns. This system here, first, the system is consistent and it has the number of equations equals the number of unknowns. So when you see this system is consistent, number of equations equals the number of unknowns, then it is very different from what we had previously. Remember previously where we had less equations than unknowns, then we had to select what becomes the free variable, then what is going to be the basic variable, and so on. Okay, for this case here, then now it is consistent and the number of equations equals the number of unknowns, and you can, no prizes for guessing that the solution here, x1, x2, and x3 is going to be the 0 vector. Okay, the trivial solution. Yes, because when you do back substitution, x3 is going to be 0. When you substitute it into here, x2 will be 0. When you substitute everything in here, this is 0, this is 0, x1 is going to be equal to 0. Okay.